So let's do an example. Let's solve this integral. Now the first thing you do is you have to decide what you want to let u equal. But in this case, see how I have this x cubed plus 1 to the 10th power? I have this other stuff over here too, but the thing to the 10th power seems like the big problem. I have something to the 10th power. I needed to make that into just one single function. And right now we have an outside function, which is like raising something to the 10th power, and then we have the inside function, which is like the x cubed plus 1. So I think that should be my good choice for u. So let's let u equal the inside function there, which is x cubed plus 1. Now I need to find du, or maybe dx, so that I can replace dx with something in terms of du. So let's take the derivative on both sides of this equation for u. So that will give me du over dx equals the derivative of the right-hand side, which would just be 3x squared. Now let's multiply both sides by dx, and we'll have du equals 3x squared times dx. Now if you look at my original integral, you can see I have this 3x squared here, and I have this dx here. So I can replace all of that with du, because I just said that du equaled 3x squared times dx. So that will work out perfectly. So now let's make my substitutions. So here's my integral, and if you want, you can rearrange it so that the 3x squared and the dx are next to each other. So now we can make our substitutions. So we know that all of this right here is equal to u. And we know that all of this is equal to du. So that gives us the integral u to the 10th power times du. So now it's a very simple integral to find. We can just use the power rule for integration. So using the power rule for integration, we know that this is going to be equal to u to the 11th power divided by 11. And then, of course, plus a constant of integration c. But we can't stop here. We want our final answer to be in terms of x. So now we just replace the u with what it equals in terms of x. And we know in this case, u equals x cubed plus 1. So just make that substitution. So then for our answer, we get x cubed plus 1 to the 11th power. That's what we plugged in for u. Then divided by 11 plus c. So this is our answer. Now, whenever you're finding integrals, it's always a good idea to check your answer by taking the derivative of your antiderivative. So we take that derivative, and it should be equal to this function that we started with up here. So let's take the derivative and check. So to find this derivative, we'll have to use the chain rule. First of all, we take the derivative of the outside function, which will give us 11 as a coefficient, but we still have the 11 we're dividing by, times x cubed plus 1 to the 10th power, times the derivative of the inside function, which would just be 3x squared. And of course, the derivative of c is just equal to 0. So then this will just give us 3x squared times x cubed plus 1 to the 10th power, which is exactly what we started with underneath the integration symbol up here. So that means that our solution is correct. So our answer checks out.